Hello, I'm Nathan Henderson, Application Engineer in FPGA Prototyping here at Synopsys. FPGA-based prototypes offer tremendous value because they help enable early system-on-chip validation and software development. But when something goes wrong, debugging a complex prototype can be challenging. So that's why the HAPS-70 system integrates visibility features to reduce the effort in debugging a prototype. Identify is the HAPS system debug tool. It provides a simulator-like interface to the internal operation of the target system. Identify allows debugging from the RTL source code, which makes debugging much more efficient since you can debug from what is familiar. This debug diagram illustrates a funnel of debug strategies that we see prototyping teams apply. Each strategy uses a particular set of identified debug features. And as you progress through the debug funnel, initial debug visibility is very wide, but then later refined for deeper analysis as faults are isolated. The first debug phase we refer to as Hello World, since it's our first chance to assess the design's operation. At this point, we have the most uncertainty about where bugs are, so we observe the activity of many signals. Signal watch points and triggers are easy to define from Identify's browser views. Click the eyeglass icon to indicate the signals you wish to view and to use as a trigger. You can even specify trigger conditions in HDL control structures, like case constructs, simply by clicking on the related line numbers. A good place to get started with instrumentation of the FPGA-based prototype is to import the verification views defined in a debug environment like Synopsys Verdi. Identify provides a variety of ways to observe HAPS-70 system operation. Trigger conditions you select determine the signal activity of the live prototype that will be displayed. VCD and FSDB export makes it easy to display waveforms. Signal states can even be annotated to the RTL. To maximize signal visibility, you can use Identify's multiplex groups to select up to 8 signal collection groups. During live debugger sessions, you can quickly switch between these groups. You can also quickly swap port or registered signals that are attached to the Identify debug logic. The incremental mode bypasses logic synthesis and FPGA placement to implement the signal swap in much less time. At this point, the problem modules should have been isolated and may exhibit sporadic faults. The next strategy is to record more sample data and refine trigger logic to isolate the problem. This state machine diagram illustrates an example of complex trigger expression logic for sample recording. Even complex protocol sequences can be detected and then sampled. State machine and complex counter triggers can be defined with the Identify GUI or via tickle scripts. During the next phase of debug, faulty blocks are isolated from the rest of the system to confirm problem spots. Our debug strategy shifts now from wide visibility to a more focused review for longer periods. Because block-level validation of IP often involves complex protocols, milliseconds of runtime may be required to be sampled to confirm operation. Identify provides options for high-capacity storage by using HAPS hardware accessories. During the final debug phase, circuit analysis, we isolate faults further. The debug strategy continues to emphasize high capacity, but also applies this feature to help correlate FPGA-based logic with system-level events. Identify's HAPS real-time debug feature for logic analyzers provides a high-capacity data storage solution which allows you to monitor internal FPGA activity alongside other system-level conditions. Identify connects internal signals via a HAPS connector to the analyzer, and it also automatically generates programming scripts for the analyzer. In conclusion, Identify provides simulator-like debug features for FPGA prototyping systems running at speed. And with the high-capacity storage options for the HAPS-70 series makes review of complex I/O protocols far easier. Thanks for watching.